Hello children, this is 6th standard maths. Chapter name is Algebra. So in this chapter, the part first video, we have solved exercise 11.1. That is the first exercise of this chapter till 8 problems we have solved. Now we shall continue the same exercise 11.1 with the 9th problem. The 9th problem is that Mother has made laddus. She gives some laddus to guests and family members. Still, 5 laddus remain. If the number of laddus mother gave away is L, how many laddus did she make? So, we will try to understand the problem, children. So, at home, mother has prepared the laddus. And the prepared laddus she will give to guests and family members. Even though after giving laddus to guests and family members, still 5 laddus get remained. Now, if the number of laddus mother gave away is L, so the number of laddus given to guests and family members is L. That is the variable L. Now we have to express how many laddus did mother make. So to solve this problem, children, let us consider L, which is given in the question itself. So let L be the number of laddus given to guests and family members. Therefore, let us write L be the number of laddus given to guests and family members. Then, number of laddus still remained is 5. That is, after giving away L number of laddus, still 5 laddus get remained means it is plus 5. Therefore, the number of laddus that mother prepared will be equal to L plus 5 is the answer for the 9th question, children. So, L is the number of laddus gave away to guests and family members. Plus 5 means still 5 laddus are remaining. Therefore, L plus 5 is the answer for the 9th question. Now look into the 10th question. Oranges are to be transferred from larger boxes into smaller boxes. So the mangoes are contained in larger boxes. So it has to be transferred into smaller boxes. When a large box is emptied, the oranges from it fill 2 smaller boxes. So to transfer to a smaller box, we have to empty that larger box. So, when emptied that larger box, 2 smaller boxes gets completely filled by the oranges. And still, 10 oranges remain outside. Even though they have transferred from larger box to 2 smaller boxes, still 10 oranges remain in the larger box. If the number of oranges in a small box are taken to be X, okay, 2 smaller boxes have been filled and they have told in the question itself to consider the number of oranges in a small box as X. Now, what is the question? What is the number of oranges in the larger box? So, what was the total number of oranges in the larger box? We have to find out. So, number of oranges was transferred to the smaller box is equal to X. Then, number of smaller boxes, that is equal to 2. So, let us write first numerical value 2. So, from the single larger box, 2 smaller boxes get filled with X number of oranges. Therefore, let us write 2X. Okay. So, 2 smaller boxes, each box get filled with X number of oranges, which can be written as 2X. Then, still 10 oranges is remaining. That we will write it as plus 10. Therefore, children, number of oranges in the larger box will be equal to 2x plus 10. Therefore, number of smaller boxes is equal to 2 and number of oranges in a small box is x, which is written as 2x. Number of oranges remaining outside is equal to 10. Therefore, number of oranges in a larger box will be equal to 2x plus 10 is the answer for the 10th question, children. This is about the exercise 11.1. Next is uses of variables. So in the first part of this chapter video, we have studied variables are usually denoted by letters and the value of the variable is not fixed. Therefore, and we also mentioned that these variables help us to write the rules and formulas which help us to solve the basic operations such as addition, subtraction, multiplication and division also. Now, this variable will help us to express many common rules in both geometry and arithmetic in a general way. So in geometry, we study the different shapes and arithmetic we mainly study on numbers. So in order to study these, the variables helps us to write the formulas, rules in the letters form. Therefore, let us try to understand the uses of these variables from rules from geometry. So, perimeter of a square. So, in a square, there are 4 sides in which all the sides of the square are equal. So, to find out the perimeter of a square, the variables helps us to find out the rule, that is the formula to find the perimeter of a square, which is equal to P, that is perimeter, which is denoted by the letter P, that is equal to 4L, where L is the length of each side of the square. Therefore, this L is also the variable. Therefore, these variables helps us to write the formulas of different shapes of geometry. For example, square. The perimeter of a square is expressed as P is equal to 4L. In the same way, a rectangle. So we know that, children, in a rectangle, opposite sides are equal and it has length and breadth. So this length and breadth are denoted by the variables L and B. Therefore, it helps, the variables helps us to write the formula to find the perimeter of a rectangle, that is given by P is equal to 2 into L plus B, where P is the perimeter, L is the length, B is the breadth, where P, L and B are the variables. This is the use of the variables in geometry. Next use of variables is writing the rules from arithmetic, which we mainly study on numbers. So, we have studied commutativity, distributivity, all these properties in arithmetic. So, how these variables helps us to write the commutativity of addition of two numbers. So, a plus b is equal to b plus a. So, a and b, these are the variables. So, to these variables, if we apply the numbers, we can solve this commutativity of addition of two numbers. For example, if we consider the value of a is equal to 2 and the value of b is equal to 2. 2 plus 2, it will be 4. And again, b plus a, where b value is 2, again a value is 2. So, if we apply the values to these variables and the basic operation used is addition, we will get the operation performed and we will get the final answer. Therefore, this is variables. With the use of letters, we can find the commutativity of addition of two numbers. In the same way, commutativity of multiplication of two numbers can also be done with the help of variables, which is expressed as a into b is equal to b into a. The basic operation performed here is multiplication. In the same way, if we give the values to a and b and perform the multiplication operation, we will arrive at the solution. Third is distributivity of multiplication over addition of numbers. Here a into b plus c is equal to a into b plus a into c. This is the rule of distributivity of multiplication over addition. In the same way, if we apply values for a, b and c and perform the operations multiplication and addition, we will come to a final answer. Therefore, these variables will help us to write the rules for arithmetic, for commutativity and distributivity also. So children, based on the uses of variables in arithmetic geometry, we shall solve the exercise problems, that is exercise 11.2. And that the first question is, the side of an equilateral triangle is shown by L. So we know that equilateral triangle, in an equilateral triangle, all the three sides are equal and all the angles are also equal. So in the problem, it is said that each side of an equilateral triangle is to be represented as L, variable L. Express the perimeter of the equilateral triangle using L. So now we need to write the formula of the equilateral triangle using the side which is given as L. So children, to write the perimeter of an equilateral triangle, we shall consider L be the number of sides, let L be the sides of the equilateral triangle. L be the sides of the equilateral triangle. Then equilateral triangle, there are how many sides, children? There are 3 sides. Therefore, to write the perimeter of the equilateral triangle, let us consider first the numerical value 3. That is the number of sides of an equilateral triangle. So each side of the triangle measures L. Therefore, 3L will be the perimeter of the equilateral triangle. Answer. L be the sides of the equilateral triangle. Number of sides is equal to 3. Therefore, the perimeter of equilateral triangle will be equal to P is equal to perimeter, which is expressed as P. So perimeter of an equilateral triangle will be equal to 3L, where 3 is the number of sides and L be the sides of equilateral triangle. Therefore, 3L is the answer for the first question. Now take the second question. The side of a regular hexagon, it is given in figure 11.10. So children, observe here, this is the hexagon which is denoted by L. Note that in hexagon there are 6 sides. 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. So there are, children, 6 sides in a regular hexagon and all the 6 sides are denoted by L. And one more point we have to remember, that in a regular hexagon, all the 6 sides are equal and the measurement is given by the variable L. Now, we have to express the perimeter of the hexagon using L. So, the answer is, how many sides does a regular hexagon have? Yes, it is 6 sides is the number of sides in a regular hexagon. L be the sides of regular hexagon. So L is the measurement of the regular hexagon. Therefore, perimeter P will be equal to 6L is the answer. Therefore, let L be the sides of regular hexagon. Number of sides is equal to 6. Therefore, the perimeter of a regular hexagon will be equal to P is equal to 6L is the answer for the second question, children. Now consider the third question. A cube is a three-dimensional figure. So, this is a cube and it is a three-dimensional figure. So, children, three-dimensional figure means it will be having length, breadth and height. When any figure has height, it is three-dimensional figure. Whereas in two-dimensional figure, only length and breadth is considered. For example, rectangle. It is in two-dimensional figure because it has length and breadth. Whereas this is a cube where it has length, breadth and height. So it is a three-dimensional figure. So children, it has 6 faces and all of them are identical squares. So in a cube there are 6 faces. All the 6 faces are made up of squares. The length of an edge of the cube is given by L. So here you can notice that to each 6 faces, let L be the length of an edge of the cube. Therefore, the answer will be length of edge of cube is equal to L, which is given in the question. Then, faces of the cube. The faces of the cube is 6, which is given in the question. Then, the length of the edge of the cube is given by L. So, children, we should consider that there are 6 faces in a cube. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There are 6 faces in a cube. To each of these 6 faces, there are 2 edges present. Okay. So, to each 6 faces, 2 edges will be present in a cube. Therefore, 6 into 2, that will be equal to 12. Therefore, the total edges present in the cube will be equal to 12. What do we need to find out, children? Find the formula for total length of the edges of the cube. Therefore, the total edges in a cube, that is equal to 12. And length of each edge of the cube is equal to 11. So, to write the formula to the total length of the edges of the cube, we need one numerical value and a variable. So, therefore, the answer will be 12L. Therefore, the length of an edge of cube will be equal to L and total faces in a cube is equal to 6. Next point, we need to remember that, children, to each 6 faces of the cube, 2 edges will be present. Therefore, to 6 faces, 2 edges are present. So, if you consider this is one face. In one face, 2 edges will be present. Therefore, 6 into 2, that is 12 edges. Therefore, 12 edges are present in a cube. Therefore, the formula to find the total length of the edges of the cube will be equal to 12L will be the answer. Therefore, 12L is the answer for the third question. Now, consider the fourth question, children, in which we have the diameter of a circle is a line which joins 2 points on the circle and also passes through the center of the circle. So, the circle is given in the figure 11.12 where AB is the diameter of the circle. So, this diameter has connected the 2 points of the circle and it has been passing through the center of the circle C. So, C is the circle, AB is the diameter. Express the diameter of the circle D, that is, diameter of the circle is represented by using the variable D in terms of its radius R. Our radius is represented using R. Therefore, children, here in the circle you can observe AB is the diameter of the circle and CP is the radius. Okay, the radius is which is from the center to any point on the circle, that will be the radius. Therefore, in the circle given, AB is the diameter represented by D. Then C is the center represented by using C. Then CP is the radius which is represented by R. Therefore, expressing the diameter of the circle D in terms of its radius R will be equal to D is equal to 2R is the formula, children. So, the diameter D will be equal to 2R. Therefore, the diameter is twice the radius value. Therefore, the answer is D is equal to 2R. Therefore, diameter of the circle in terms of its radius is given by the formula D is equal to 2R, where D is the diameter and R is the radius. Therefore, diameter is equal to twice the radius value. This is the answer for the fourth question, children. Now consider the last question of this exercise 11.2, that is fifth problem. To find sum of three numbers 14, 27 and 13, we can have two ways. To find the sum of the three numbers which is given in the problem, we are having two methods. The first method is, we may add first 14 and 27 to get 41 and then add 13 to it to get the total sum 54. This is the first method. And the second method is, we may add 27 and 13 to get 40 here and then add 14 to get the sum that is equal to 54. So, the possible two ways of adding these three numbers are given like this, children. First, 14 and 27 is added. We will get 41 and then it is added to 31. So, the total sum will be equal to 54. Okay. In the same way, now to the right side part, the alternate method will be, when we add 27 plus 13, we get 40. And then add 14, we will get the sum 54. So, on both the ways of performing the addition to these three numbers, we will get the answer equal to 54. For both the cases, the answer is 54. Okay, which is can be done by for three numbers. And this property is known as the associativity of addition of numbers. So, express this property which we have already studied in the chapter on whole numbers. So, in whole numbers, children, we have studied commutativity, associativity, distributivity and also associativity property also. So, based on that, we have to express in a general way by using the variables A, B and C. So, in the beginning, I have told how we can express this commutativity, distributivity using the variables. Now, in the same way, whereas we are given with the numbers 14, 27 and 13. Now, we have to express these numbers in the form of variables so that we will come to the associativity of addition of numbers property. So, to do this problem, let us consider the value of A is equal to 14, value of B is equal to 27 and value of C is equal to 13. To order to get the three variables A, B and C, we have three numbers. So that let A is equal to 14, B is equal to 27 and C is equal to 13 to represent these three numbers. We have taken the variables A, B and C. Now, we shall substitute this A, B and C to this, children. So, A value is equal to 14. A plus 27 is equal to B. Put a bracket. Plus 13 is equal to C. That will be equal to 14 is equal to A plus 27 is equal to B plus 13 is equal to C. 13 is equal to C. Therefore, the associativity of addition of numbers using these variables, we can write a general rule such that A plus B plus C is equal to A plus B plus C, where the value of A is equal to 14, B value is equal to 27, C value is equal to 13. Using the variables, we can write the rule for the associativity of addition of numbers such as A plus B plus C is equal to A plus B plus C. Therefore, in both the sides also, we can get the answer 54. And this is the answer for the fifth question, children. This is about the exercise 11.2, in which we have solved the problems based on uses of variables in arithmetic and geometry. Hope it is clear, children. Thank you.